Hello, welcome. In this short video, let us look at an example illustrating how to use simple Cartesian coordinate geometry and joint CDFs to calculate the probability of a union of two events. That is, given the events A defined as event x1 less than x less than or equal to x2 and event B defined as y1 less than y less than or equal to y2, we want to calculate the probability of event A union B. That is, we want to calculate the probability that x1 is less than x less than or equal to x2 union y1 less than y less than or equal to y2. Graphically, this can be represented as, using coordinate geometry, we can easily represent this as follows. Assuming that this is x-axis, this is the y-axis, and this is the value x1, and this is value x2, and this is y1, and this is y2. Then clearly the region A union B is defined as, or can be represented as follows. That is, this is obviously the event B. This is event B, and the event A is represented by this is the event A. This is event A. So the union of event A and B is basically the two regions represented by this plus shaped region. That is the region in green and region in black. That is, we want to calculate the probability of this total region. From the definition of probability of A union, that is the probability of A union B is equal to the sum of probabilities of A and B minus probability of the intersection A intersection B. Graphically, we can clearly see that a formula is justified as the summation of this region denoted by the event B and the sum of the probability of the event A minus the probability of this rectangular region, because we are basically adding this region twice in the original sum or the first sum. So we want to subtract this probability of this intersection region once to basically account for the double addition. So we can easily calculate the probability of event A as probability of x1 less than x less than or equal to x2, which is by definition equal to the difference between the marginal CDFs at x2 and x1. So the first term is available. Now the second term is clearly equal to the probability that y is between y1 and y2, which is also given by the difference between the marginal CDFs at y2 and y1. Now the tricky part is the calculation of this intersection, the intersection event, that is probability of A intersection B is equal to how much? That is, we are basically talking about the probability of this rectangular region between y1 and y2 and x1 x2, that is this region. We want to calculate the probability of that region. From a previous video, we have actually learned that the probability of this region, the rectangular region bounded by x1 and x2 on the x-axis and y1 and y2 on the y-axis, is basically given by the probability of this region A intersection B it can be calculated by following representation. The probability of this rectangular region can be calculated as follows. Now let us construct these different rectangular, these different boundaries. That is probability of this region represented by probability of x less than x2 and y less than or equal to y2. That is this region. This is probability of x less than x2 and probability of y less than y2. And then we have, and the region in blue is probability of x less than or equal to x1 and y less than or equal to y1. We know that this is x1 and this is x2 and this is y1 and this is y2. And next we have to subtract this region and this region. That is the regions represented by green and this one. So this one corresponds to probability of x less than x1 and y between y1 and y2. And this one corresponds to probability that x is between x1 and x2 and y is less than or equal to y1. Since this is y1 and this is x1. And so the probability of this region can be easily calculated as the difference between this the region of in red and the regions in and the sum of the probabilities of the regions in green and blue. That is probability of A intersection B, that is equal to probability of x1 less than x less than or equal to x2, comma y1 less than y less than or equal to y2, that is the small rectangular region, is equal to the probability of the region in red, that is probability of x less than or equal to x2, y less than or equal to y2, minus the sum of the probabilities of the region in blue, that is probability of x less than x1, y less than or equal to y1, plus probability of the regions in green, that is given by sum of probabilities of x less than or equal to x1, comma y1 less than y less than or equal to y2, plus probability of x1 less than x less than or equal to x2, comma y less than or equal to y1. So the probability of A intersection B is given by this expression, that is the difference between the region in red minus the sum of the different probabilities of the regions in green and blue, which is given by this expression. And in the previous video we already proved that this should be equal to the difference between the CDF fx, y of x2, y2 minus fx, y of x1, y1, and this is equal to minus fx, y of x1, y2 plus fx, y of x1, y1 minus fx, y of x2, y1 minus plus fx, y of x1, y1. So the probability of A intersection B is given by the CDF at x2, y2 minus the CDF at x1, y2 minus CDF at x2, y1 plus the CDF at x, y of x1, y1. So this is the probability of A intersection B, that is the probability of the rectangular region represented by this A intersection B, and hence the probability of A union B is given by probability of A plus probability of A and probability of B minus probability of A intersection B, given by this expression. Thanks for watching.